These next few lessons are going to take us back into the coordinate plane. So we're working on rotations first, and then we'll do some reflections and finish up with some translations and multiple transformations. So with this section about rotations, we're starting off with diagram below. You have segment AB on your grid with endpoints at 1, 5, and 7, negative 3. And so the directions are saying to draw A prime, B prime after a 90 degrees clockwise rotation around the origin. What you'll recall from previous units is anytime we need to do a rotation around the origin, we're going to switch quadrants according to the number of degrees. So if it's 90 degrees, we go one quadrant. Going counterclockwise means from quadrant 1 to quadrant 2, or quadrant 4 to quadrant 1, basically goes around to the left. So point A was in quadrant 1, it's going to move to 2, and point B was in quadrant 4, and it's going to quadrant 1. The other thing that happens is the order of the numbers switches. So what was X becomes Y, and what was Y becomes X, and then you just figure out the signs from there. So with point A at 1, 5, I know it's going to be some signs, some format of 5, 1, because I have to switch those numbers, and the question just becomes which sign is which, but because it's going to quadrant 2, it's going to be a negative X and a positive Y, so that's where the negative 5, 1 comes from. You can also see that the distance from the origin at point A is a vertical 4 and a vertical 5 and horizontal 1, and it becomes a horizontal 5 and a vertical 1. So you can see that rotation that way too. Same thing happens with B. The 7 and the 3 switch to become 3 and 7, and because we're in quadrant 1 now, everything's positive. So for part B, to find the length of AB and A prime B prime, we're just using the distance formula. I've got it there formalized, but if you wanted to do it with just using Pythagorean theorem, you can say that the A and B are 6 units apart horizontally and 8 units apart vertically, and therefore you have 8 squared plus 6 squared, which is 100. Total comes out to 10. And the same thing happens with A prime B prime. And what that tells us as a reminder is that the length of the segment is staying the same after a rotation. And we know that about rotations because all angles and segments are supposed to be preserved. So in the coordinate plane, we're only going to work with rotations that are multiples of 90. And we could see 90, we could see 180, we could see 270. So in exercise 2, we're talking about the image of CD after a rotation by 180. So if a 90-degree rotation switches the coordinates once, a 180 rotation would switch them twice and therefore put them back where they were. But what ends up happening is the signs change because it goes to the opposite quadrant. So if point C was in quadrant 2, it's going to move to quadrant 4 after a 180-degree rotation, but it would have switched to 8, 3 and then back to 3, 8. So that's why we have 3, 8 again, and it's negative 8 because we're in quadrant 4 for C prime. Same thing for point D. Point D is moving from quadrant 1 into quadrant 3, so the 9 and 2 stay intact, they just change their signs. Looking for the slope of these, we have the slopes at negative 1/2 for both segments. And so what's true about those segments is they end up being parallel. And that will happen no matter what. If we have a 180-degree rotation, we will end up with parallel segments no matter where they are. Okay, so that's page 30. It's not 33 in your packet. It's something different. It would be page 13 in yours. So on to page 14, looking at the top here at exercise 3. So we have a point AB being rotated by 90 degrees clockwise. So no matter where that point is, A could represent positives, could represent negatives, same thing with B. If we rotate 90 degrees clockwise, what's happening is it's going to go into the next quadrant the other direction from what we're used to seeing. So if we assume that point AB is in quadrant 1, then when it rotates, A and B will switch, and we would go to quadrant 4, which would make the second coordinate be the negative 1. So we switch the A and the B, and then we put the minus on the A in the second slot, because that's where the sign changed. And no matter which quadrant we started in, it would be the second number that changes when we go that direction. So that's exercise 3. In exercise 4, you've got your triangle drawn, you've got a rotation point at D, and we're trying to rotate 90 degrees. So this is a little bit tricky because what ends up happening here is we have to recalibrate the rotation center. And so point D creates two new axes, so to speak. All right, so if you can picture a horizontal line through D and a vertical line through D, those two lines create new quadrants. So point A is exactly 8 units horizontal from point D. So when it rotates, it's going to become exactly 8 units vertical from point D, and it's going to end up, it's counterclockwise, so that's going to make it rotate from what would be the x-axis through D around to the y-axis through D. And you can see I drew those lines in here as well. So that would be a good idea for you too. Take a highlighter or take a marker, draw a horizontal line through D, and draw a vertical line through D to make new axes. And then you're just doing the same procedure that we're used to doing. For part B, it's at -2, -2, but really from point D, it's actually -6 back to the left and -5 down from D. So if we take the 6 and the 5 and we switch them, we get 5 and 6 from D. So what we have to do is count 5 units horizontal from D and 6 units vertical down from D. And that's why my B prime is placed where it is. So the whole concept of switching numbers holds. It's just that we're not switching the coordinate itself, we're switching the distances from the rotation point. So if it was 6 and 5, it becomes 5 and 6, and it goes to the next quadrant. And 8, -1 for point C is actually at, if you want to think about it this way, it's at 4, -4 when we're talking about taking it from point D. So if I take the 4 and the 4 and I switch them, I still get 4 and 4, and I just go to the next quadrant, and I'm up here at C prime. And we could talk some more about this one in class. I know this one's a little bit trickier, but just know that we're counting from a specific point and not from the origin. And finally, in exercise 5, if point A is rotated 180 degrees clockwise around point B, where would it fall? So -3, 7 and 2, -5, that A point is left 5 and up 12 from B. So if it's -5 and 12 from B, it's going to go +5 and down 12 on the other side of B. So if I add 5 to the B coordinate, I get 7. And if I subtract 12 from the second B coordinate, I get -17. So that's where it would fall. With a 180-degree rotation, you're essentially reusing the slope on the opposite side. It's just going to come as a semicircle, like a linear pair on the other side. So choice 1 for that one.